for this power series, I'm looking at it and it is centered around what number? Centered around 3. This power series is centered around 3. And I know that because it has x minus 3 to the power. This means for this power series, I was going to go over this again with you that I mentioned yesterday. This means that the series certainly converges when x equals 3. Because when x is 3, what do I have? All zeros. So it'd be 0 plus 0 plus 0 plus 0. And so it's going to converge when x is 3. It might converge for other numbers as well. And that's what we need to figure out. So I'm going to draw the little number lines. Here are the possibilities. And these are just kind of going over some of the notes actually from yesterday. You would not have to show the possibilities when you're working the problem. Okay, I'm just wanting to try to explain some of what's happening here. So possibilities, this is a number line. It's going to converge for sure when x is 3. Now, it might converge on some interval around 3. And if it does, it's going to be the same distance on each side of 3. It would be, the book uses an r, like 3 minus r and 3 plus r. Now, it could be open parentheses. It could be this, if I were to graph this. Could be open on both sides. It could be closed on one side and open on the other. It could be flipped, open, and then closed. And I'm running out of space here. I'll put this one underneath. It could be closed and closed. So those are the possibilities for case number 2, I will call it. And then the third possibility, it's going to converge at 3. It could converge on the entire number line. So your job is to figure out which of those it is. To do this, we use the ratio test. Use the ratio test. And so I'll work this problem on the next page. And there's this problem we're looking at. And for this, the sum as in goes from 1 to infinity. X minus 3 to the n over n. A sub n is this expression. So I need to form this ratio, a sub n plus 1 over a sub n, the absolute value of that. And I've learned from 1552 students a while back, x minus 3 to the n plus 1 over n plus 1. I don't really have to form the whole complex fraction. I might want to go straight to the step of multiply by the reciprocal, n over x minus 3 to the n. And simplify this. We'll do exactly what we did when we covered that section on the ratio test. I will have, get the pieces that are similar together. So form this fraction, n over n plus 1, and then form the other fraction with the x minus 3. X minus 3 to the n plus 1 over x minus 3 to the n. I cannot drop the absolute value signs here, but I will reduce n over n plus 1 times, what's this part going to be? X minus 3. I did not do the limit yet, so I've kept the n over n plus 1. At this point, I'm ready to do the limit from the ratio test. The limit as n approaches infinity of n over n plus 1 times x minus 3. The only part that has the n's in it is n over n plus 1. That limit equals what? This is 1. When I do the limit, I'll write that in pink over it, but that would actually be the next step here. This equals the absolute value of 1 times x minus 3. Now that I have done the limit, I take limit as n approaches infinity off the problem, and this limit is just the absolute value of x minus 3. Now you have to think about what the ratio test tells you. The ratio test says if this limit is less than 1, what happens? Converges? Absolutely. And then it says if this limit is greater than 1, what happens? It diverges. What does it say if this limit equals 1? You don't know. That's your endpoint on that little interval I talked about. Might be open circle, might be closed circle. That's your endpoints. So what we'll do is take this, what we found the limit to be, and we're going to say it's less than 1. So now put the absolute value of x minus 3 less than 1, because we know that the series converges for those values of x, because then the limit, the absolute value is less than 1, so we'd be good. And so you need to solve this inequality. Now this inequality, it's been a while since you've seen inequalities like that, unless you were in class yesterday, right? So this is taught in remedial algebra classes, just to kind of let you know where you might have seen it. High school algebra. So I'll say the absolute value of x minus 3 is less than 1. When you saw this in high school, you may have seen them say case 1, case 2. I just do it like this. I can sandwich this x minus 3 between -1 and 1. And then work this out. Add 3 to all 3 parts. You're going to get 2 is less than x is less than 4. So what I know, this series converges on this interval. I'll just draw it on the graph. 3 is in the middle, 2 is here, 4 is here. I know it converges for this, but this is not the final answer. Or it might be, but I don't know yet. I have got to check 2 and 4 separately. So I'm going to say that we must check x equals 2 and x equals 4 separately, because those two numbers are where the limit, who knows what I'm about to write? The limit equals 1. And the ratio test right there is inconclusive. So what I'll do is I will go back to the original problem, and plug in those values for x. Go back to the series. N goes from 1 to infinity of x minus 3 to the n over n, and plug in x equals 2 and x equals 4, and use some of the tests from earlier in the chapter. Let's see, I'm going to have this. When x equals 2, I get the sum as n goes from 1 to infinity of 2 minus 3 to the n over n. Well, what is 2 minus 3? Negative 1. So I get the sum as n goes from 1 to infinity of negative 1 to the n over n. Now this is a very small part of a much bigger problem. I'm not looking for a full-blown argument here. You hopefully would be able to look at this and know, what does this do? Converges. It is the alternating harmonic series, but alternating series test applies here. This converges. You don't have to give a big, long, whole paragraph explanation at this point. We've already covered up 3 pages of stuff. Okay, so when x is 2, it converges. When x is 4, I get the sum as n goes from 1 to infinity, 4 minus 3 to the n over n. And well, what is that? That's 1 to the n over n, but 1 to the n is what? That's just 1. That's 1 over n. What does this do? Diverges. Harmonic series. So I'm looking at my little number line right here, and I want to take the 2, reject the 4, so it converges. If I use brackets, 2 comma 4 parentheses. That's the answer for the x values where this series converges. Now there's a couple of other words I haven't mentioned. I'll mention them here, a couple of definitions. This interval, the interval bracket 2 to 4, oh, it's a parentheses, isn't it? Let me make sure that's clear. Bracket 2, 4, parentheses. This interval is called the interval of convergence. So there's a phrase you'll see in the book. And on the number line, the distance from the center, where it's centered at, to that end point, and whether you use brackets or parentheses here for this part, you know, the distance from 3 to 2 is what? Is 1. The distance from 3 to 4 is 1. That's that little r I had written when I wrote it in the generic form. So in this, there's r, it equals 1. So r is called the radius of convergence. So r is called the radius of convergence. On some of the problems, they ask you to find the interval of convergence and the radius of convergence. Let's zoom out a little bit. Okay.